Fair division. Whether it is two kids sharing a candy bar or a couple splitting assets during a divorce, there are times in life where items of value need to be divided between two or more parties. While some cases can be handled through mutual agreement or mediation, in others, the parties are adversarial or cannot reach a decision all feel is fair. In these cases, fair division methods can be utilized. Fair division method. A fair division method is a procedure that can be followed that will result in a division of items in a way so that each party feels they have received their fair share. For these methods to work, we have to make a few assumptions. The parties are non-cooperative, so the method must operate without communication between the parties. The parties have no knowledge of what the other players like, their valuations. The parties act rationally, meaning they act in their best interests and do not make emotional decisions. The method should allow the parties to make a fair decision without requiring an outside arbitrator or other intervention. With these methods, each party will be entitled to some fair share. When there are n parties equally dividing something, that fair share should be 1/nth. For example, if there were 4 parties, each would be entitled to a fair share of 1/4 of 25% of the whole. More specifically, they are entitled to a share that they value as 25% of the whole. Fair share. What n parties divide something equally, each party's fair share is the amount they are entitled to. As a fraction, it will be 1/nth. It should be noted that a fair division method simply needs to guarantee that each party will receive a share they view as fair. A basic fair division does not need to be envy-free. An envy-free division is one in which no party would prefer another party's share over their own. A basic fair division also does not need to be a Pareto optimal. A Pareto optimal division is one in which no other division would make a participant better off without making someone else worse off. Nor does fair division have to be equitable. An equitable division is one in which the proportion of the whole each party receives, judged by their own valuation, is the same. Basically, a simple fair division doesn't have to be the best possible division. It just has to give each party their fair share. Example 1. Suppose that 4 classmates are splitting equally a $12 pizza that is half pepperoni, half veggie that someone else bought them. What is each person's fair share? Since they all are splitting the pizza equally, each person's fair share is $3 or pieces they value as 25% of the pizza. It is important to keep in mind that each party might value portions of the whole differently. For example, a vegetarian would probably put 0 value on the pepperoni half of the pizza. Example 2. Suppose that 4 classmates are splitting equally a $12 pizza that is half pepperoni, half veggie. Steve likes pepperoni twice as much as veggie. Describe a fair share for Steve. He would value the veggie half as being worth $4 and the pepperoni half as $8, twice as much. If the pizza was divided up into 4 pepperoni slices and 4 veggie slices, he would value a pepperoni slice as being worth $2 and a veggie slice as being worth $1. If we weren't able to guess the values, we could make a more algebraic approach. If Steve values a veggie slice as worth X dollars, then he'd value a pepperoni slice as worth 2 times dollars, twice as much. For veggie slices would be worth 4 times X equals 4X dollars, and 4 pepperoni slices would be worth 4 multiplied by 2X equals 8X dollars. Altogether, the 8 slices would be worth 4X plus 8X equals 12X dollars. Since the total value of the pizza was $12, then 12x equals $12. Solving, we get x equals $1. The value of a veggie slice is $1, and the value of a pepperoni slice is 2x equals $2. A fair share for Steve would be 1 pepperoni slice and 1 veggie slice. $2 plus $1 equals $3 value. 1/2 pepperoni slices, 1/2 multiplied by $2 equals $3 value. 3 veggie slices, 3 multiplied by $1 equals $3 value, or a variety of more complicated possibilities. You will find that many examples and exercises in this topic involve dividing food. Dividing candy, cutting cakes, sharing pizza, etc. This may make this topic seem somewhat trivial, but instead of cutting a cake, we might be drawing borders dividing Germany after World War II. Instead of splitting a bag of candy, siblings might be dividing belongings from an inheritance. Mathematicians often characterize very important and contentious issues in terms of simple items like cake to separate any emotional influences from the mathematical method. Because of this, our requirement that the players not communicate about their preferences can seem silly. After all, why wouldn't 4 classmates talk about what kind of pizza they like if they're splitting a pizza? Just remember that in issues of politics, business, finance, divorce settlements, etc., the players are usually less cooperative and more concerned about the other players trying to get more than their fair share. There are 2 broad classifications of fair division methods: those that apply to continuously divisible items and those that apply to discretely divisible items. Continuously divisible items are things that can be divided into pieces of any size, like dividing a candy bar into 2 pieces or drawing borders to split a piece of land into smaller plots. Discretely divisible items are when you are dividing several items that cannot be broken apart easily, such as assets in a divorce, house, car, furniture, etc. Divider-chooser. The first method we will look at is a method for continuously divisible items. This method will be familiar to many parents. It is the you cut, I choose method. In this method, one party is designated the divider and the other the chooser. Perhaps with the coin toss, the method works as follows. Divider-chooser method. 1. The divider cuts the item into 2 pieces that are, in his eyes, equal in value. 2. The chooser selects either of the 2 pieces. 3. The divider receives the remaining piece. Notice that the divider-chooser method is specific to a 2-party division. Examine why this method guarantees a fair division. Since the divider doesn't know which piece he will receive, the rational action for him to take would be to divide the whole into 2 pieces he values equally. There is no incentive for the divider to attempt to cheat since he doesn't know which piece he will receive. Since the chooser can pick either piece, she is guaranteed that one of them is worth at least 50% of the whole in her eyes. The chooser is guaranteed a piece she values at least 50%, and the divider is guaranteed a piece he values at 50%. Example 3. 2 retirees, Fred and Martha, buy a vacation beach house in Florida together, with the agreement that they will split the year into 2 parts. Fred is chosen to be the divider and splits the year into 2 pieces, November through February and March through October. Even though the first piece is 4 months and the second is 8 months, Fred places equal value on both pieces since he really likes to be in Florida during the winter. Martha gets to pick whichever piece she values more. Suppose she values all months equally. In this case, she would choose the March through October time, resulting in a piece that she values as 8/12, equals 66.7% of the whole. Fred is left with the November through February slot, which he values as 50% of the whole. Of course, in this example, Fred and Martha probably could have discussed their preferences and reached a mutually agreeable decision. The divider-chooser method is more necessary in cases where the parties are suspicious of each other's motives or are unable to communicate effectively, such as 2 countries drawing a border or 2 children splitting a candy bar. Things quickly become more complicated when we have more than 2 parties involved. We will look at 3 different approaches, but first, let us look at one that doesn't work. How not to divide with 3 parties. When first approaching the question of 3-party fair division, it is very tempting to propose this method. Randomly designate one participant to be the divider and designate the rest choosers. Proceed as follows. 1. Have the divider divide the item into 3 pieces. 2. Have the first chooser select any of the 3 pieces they feel is worth a fair share. 3. Have the second chooser select either of the remaining pieces. 4. The divider gets the piece left. Example 4. Don't do this. Is it bad? Suppose we have 3 people splitting a cake. We can immediately see that the divider will receive a fair share as long as they cut the cake fairly at the beginning. The first chooser certainly will also receive a fair share. What about the second chooser? Suppose each person values the 3 pieces like this. Since the first chooser will clearly select piece 1, the second chooser is left to select between piece 2 and piece 3, neither of which she values as a fair share, 1/3 or about 33.3%. This example shows that this method does not guarantee a fair division. To handle division with 3 or more parties, we'll have to take a more clever approach. Lone divider. The lone divider method works for any number of parties. We will use n for the number of parties. One participant is randomly designated the divider, and the rest of the participants are designated as choosers. Lone divider method. The lone divider method proceeds as follows. 1. The divider divides the item into n pieces, which we'll label S sub 1, S sub 2, and so on S sub n. 2. Each of the choosers will separately list which pieces they consider to be a fair share. This is called their declaration or bid. 3. The lists are examined. There are 2 possibilities. A. If it is possible to give each party a piece they declare, then do so, and the divider gets the remaining piece. B. If 2 or more parties both want the same pieces and no others, then give a non-contested piece to the divider. The rest of the pieces are combined and repeat the entire procedure with the remaining parties. If there are only 2 parties left, they can use divider chooser. Example 5. Consider the example from earlier in which the pieces were valued as. Each chooser makes a declaration of which pieces they value as a fair share. In this case, chooser 1 would make the declaration piece 1. Chooser 2 would make the declaration piece 1. Since both choosers want the same piece, we cannot immediately allocate the pieces. The lone divider method specifies that we give a non-contested piece to the divider. Both pieces 2 and 3 are uncontested, so we flip a coin and give piece 2 to the divider. Piece 1 and 3 are then recombined to make a piece worth 70% to chooser 1 and 70% to chooser 2. Since there are only 2 players left, they can divide the recombined pieces using divider chooser. Each is guaranteed a piece they value as at least 35%, which is a fair share. Example 6. Suppose that Abby, Brian, Chris, and Dorian are dividing a plot of land. Dorian was selected to be the divider through a coin toss. Each person's valuation of each piece is shown below. Based on this, their declaration should be Abby, piece 2, piece 4, Brian, piece 1, piece 2, piece 4, Chris, piece 2. This can be settled simply by awarding piece 2 to Chris, piece 4 to Abby, piece 1 to Brian, and piece 3 to Dorian. Each person receives a piece that they value as at least a fair share, 25% value. Last diminisher. The last diminisher method is another approach to division among 3 or more parties. The last diminisher method. In this method, the parties are randomly assigned in order, perhaps by pulling names out of a hat. The method then proceeds as follows. 1. The first person cuts a slice they value as a fair share. 2. The second person examines the piece. A. If they think it is worth less than a fair share, they then pass on the piece unchanged. B. If they think the piece is worth more than a fair share, they trim off the excess and lay claim to the piece. The trimmings are added back into the to be divided pile. 3. Each remaining person in turn can either pass or trim the piece. 4. After the last person has made their decision, the last person to trim the slice receives it. If no one has modified the slice, then the person who cut it receives it. 5. Whoever receives the piece leads with their piece and process repeats with the remaining people. Continue until only 2 people remain. They can divide what is left with the divider-chooser method. Moving knife. A somewhat different approach to continuous fair division is called the moving knife procedure. Moving knife method. In this method applied to a cake, 1. A referee starts moving a knife from left to right across a cake. 2. As soon as any player feels the piece to the left of the knife is worth a fair share, they shout stop. The referee then cuts the cake at the current knife position and the player who called stop gets the piece to the left of the knife. 3. This procedure continues until there are only 1 player left. The player left gets the remaining cake. Sealed bid methods. The sealed bids method provides a method for discrete fair division, allowing for the division of items that cannot be split into smaller pieces, like a house or a car. Because of this, the method requires that all parties have a large amount of cash at their disposal to balance out the difference in item values. Sealed bids method. The method begins by compiling a list of items to be divided. Then, 1. Each party involved lists in a secret a dollar amount they value each item to be worth. This is their sealed bid. 2. The bids are collected. For each party, the value of all the items is totaled and divided by the number of parties. This defines their fair share. 3. Each item is awarded to the highest bidder. 4. For each party, the value of all items received is totaled. If the value is more than the party's fair share, they pay the difference into a holding pile. If the value is less than the party's fair share, they receive the difference from the holding pile. This ends the initial allocation. 5. In most cases, there will be a surplus or leftover money in the holding pile. The surplus is divided evenly between all the players. This produces the final allocation.